Hello, this is Math 2270 from the College of DuPage for summer 2020, and we are finishing up the discussion about when I left you last time. I left you with this problem. If you solved it, that's good. If not, give it a go now. Let's see how you did. So we divide both sides by x. We realize that x is bigger than 0 in this problem, and we use the fact that the difference of the logarithms is the logarithm of the quotient. So now I do my change of variable and I let v is equal to y over x. So then we have this, and we're solving for v prime, and we're fully separating the variables, and this is what we get when we've separated the variables. These are all v's, these are all x's. Now we're going to integrate both sides, and here we're using a substitution. U is equal to the natural logarithm of 1 over v minus 1. We get this. We move the minus sign to the other side, and we're working to solve for v. So what we're going to do is exponentiate both sides once. We're going to be very generous with our constant. We'll change the constant, but just still call it c. So e to the c is the new c. And then we're going to solve for v. So we solve for the natural logarithm. Then we exponentiate yet again, getting this. And we turn both sides upside down, so v is equal to this. Now we will reverse our substitution. Y over x then is equal to that. So y is equal to this. We'll use our initial condition. When x is 1, y is 4, to find out what c is. And so the solution then is y of x is equal to this expression. We clearly need to avoid x equal to 0, so either it's x greater than 0 or x less than 0. The initial condition tells us it's x is greater than 0. Like so many things in life, it is a process. You can use a substitution x is equal to vy instead of the one we used, and then in that case dx is going to be this, and you will also get a separable equation. Also, it can happen that after using one substitution, you may run into an integral that you don't know how to do, and so switching substitution happens. Again, it is a process. Let's try another one now. This is a different substitution. We're talking about a differential equation in the form dy dx is equal to f of ax plus by plus c. Now if you let u be the argument of this function, and sometimes you include the constant, sometimes you don't, they will turn this into a separable differential equation. Let's try this one. So give it a go and let's see how you do. Oh, I'm going to ask you to do it this way. Let v be 4x minus y without the 1. It's you can do it the other way, but this might even be cleaner. Let's see how you did. So we let v equal 4x minus 1, then v prime is this. So then we substitute v is equal to this into the equation, and we know that y prime is 4 minus v prime, and so on and so forth. And we are going to then do this and separate the variables. So now we have the v's on this side and the dx on this side. Now, the easiest way to integrate this is to just expand this and factor it and use partial fractions. We reviewed that in the take-home packet. And so what happens is we integrate both sides. Here, the partial fraction decomposition gives you this. We integrate it, and so it is going to end up being the difference of the logarithms, and ultimately the quotient of a log is equal to this. And here we multiplied all the way through by 4, and so c isn't c anymore. C is 4 times the original c. Now we're going to exponentiate both sides because we're solving for v, and then we'll eventually solve for y. So we exponentiate both sides, getting this, and again we change the definition of c. Instead of it being c, it's going to be replaced by e to the c, but we're still going to call it c. And now we have to solve this expression for v. Make sure you follow this step, but we solve this for v, and we find that v is equal to this. And now we can substitute what v was in terms of x and y and solve for y. We get this. The only thing that remains is to figure out what the constant is. We're going to use when x is equal to 0, y is equal to 2. We find out c is minus 3, so this is the final answer. Note that this denominator is never equal to 0, so the interval of validity is all real numbers, minus infinity to positive infinity. Here's one more. You know what to do. Let's see how it goes. So this is the substitution we do. This is v prime, and we begin to separate the variables. And we end up with the variables being separated in this way. Notice here we divided top and bottom by the same thing so that that actually worked. We multiply by 1 in a clever way. So this is v's, this is x's. So we integrate both sides getting this, and then we exponentiate both sides getting this. Notice that we're starting to play very fast and loose with the constants. This c is really e to the c. We solve this then for v. We find that v is equal to minus the natural logarithm of 9 minus c e to the x. Now we replace v with what it is in terms of x and y, and we solve, and we get this expression. And we apply the initial condition, solve for c. c is 8, and so we have this is our solution. Now for the interval validity, this must be greater than 0, and so that means that e to the x is less than 9 over 8, and so that's e being less than the natural logarithm, or x being less than the natural logarithm of 9 over 8. And that's our interval validity because that contains 0. Okay, so now we are finished with homogeneous equations. We've done this work. We're going to be going back to the beginning. Not as far back as the Big Bang, but back to the beginning, and we're going to be talking about introductory matters. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and of others.